For those who aren't familiar with them, Cel Fi specializes in smart cellular coverage solutions that we'll be highlighting today. Before I turn it over to Jim, I'd like to mention a couple important items throughout the webinar. If you have any questions on the material being presented, please enter them into the question box so we can address them during the Q&A at the end. And following the Q&A, please take a minute to complete the survey that will appear on your screen, as we'd really appreciate getting your feedback. And with that, let's jump right in. I'll hand it over now to Jim from Cel Fi to get us started.
Thanks, Austin. Hopefully everybody can hear me okay. Again, as he said, my name is Jim Loddig. I'm with Cel Fi. We are based here in what is normally sunny San Diego, California. Unfortunately, it is raining today and will be for the whole week. So it's a little bit different than we're used to, but we'll deal with it. So I appreciate everybody joining today. We're hoping to just cover some information regarding how our technology can really help your clients as you go out and run into buildings. We're very familiar with companies like yours that are on the phone that support a lot of IT functions, but are also in connection with a lot of buildings that have challenging coverage areas. So I'll start our presentation by talking a little bit about the background of the company, because I think it's important to understand our DNA and where we come from and who we are, because it'll make a little bit more sense on the rest of the as we go through the rest of the presentation. So our company has been around for over 10 years, but primarily really up until maybe the last 3 or 4 years. If you have heard of us, you probably have only heard of us in the last 3 or 4 years, because primarily we got our start and still do a lot of business directly with the carriers like AT&T and T-Mobile and Verizon here in the States. But we also got our start and do a lot of business worldwide. So we do business in Australia, Europe, Asia, all these different points of the world, and primarily all those relationships are done with the carriers themselves. But if anyone's familiar with 4 or 5 years ago, the FCC kind of changed some things in the code, and it allowed us to be able to do business in this distribution reseller network that we currently operate in. We still do business directly with the carriers, but as I mentioned, a lot of our relationships started there. So everything we do is designed around protecting the carrier's network, making sure that we don't create and raise the noise floor of their network at all, because they are our best friends as well. So much like you guys, I'm sure you don't want to get involved in a carrier dispute, and neither do we. So all of our technology is kind of based around that. It's the only carrier-grade smart cellular coverage solution out there. And we're going to be getting more into the details about what makes our product different. And so we'll start there by talking a little bit about the uniqueness of our product. I always say that our company is definitely an engineering company first and a sales company way second. If you walked into our headquarters here, it's primarily engineers with a state-of-the-art laboratory that we do all of our testing and product development in as well. But basically, how our product is different starts right here in the lower left corner. It is a chipset that we develop. It's proprietary to us, along with some software that we've developed and as well, and then independent radios that all make up this technology that we're going to dive deeper into. In addition to that, we also have our own cloud system and our own apps that we create to communicate with the technology that allows, in some cases, in the case of the cloud platform, to allow you to monitor all those things remotely. So this chipset, though, is going out and it's looking for specific bands and frequencies within the carrier's network, and it's just boosting that. It's trying to pick and combine with the software. It's going out to select the best quality signal too. So it's not necessarily the most powerful signal that it's looking for. It's looking for the best quality signal. And there's some things that allow us, because of this technology, that the FCC even sees us as different than if anyone has a background in any of the passive systems out there, passive DAS. We're more of a hybrid DAS solution, so we're a good in-between option between the passive and the active systems. And we'll get into a little bit more about what that all means later in the presentation. So as I mentioned, we have that relationship with the carriers. All of our products go through all the carriers' labs. They actually come here as well to do testing in our laboratory, but it goes through the same process that your phone goes through to be on their network. So all of our products are not only carrier safe, they're also approved and endorsed by the carriers, and they fit into some very unique areas within the FCC code, which allows for some big advantages. So I'll kind of start out by talking small to large locations. So to give you a little bit of a history on our company, this is where we got our start and still do quite a bit of business, frankly. And this is a product that is primarily used for either residential or small office locations. It is a product that is wireless. You literally put this network unit into the area where you at least have 1 bar of LTE signal, and you put this other unit, the coverage unit, into the area where you need coverage. You create a coverage bubble wirelessly within the area of the home or office, and it covers about anywhere from 10 to 15,000 square feet in coverage. This is how we got our start. So we started with AT&T with this product. It is private labeled through T-Mobile, so if anyone has those two providers, you probably if you had coverage issues, sometimes they will send these to you as customer retention items, and so that's how we got our start. But all these products use the same chipset, same technology. It's just a different distribution method of how it's used. So the next product that I'll just mention, and we'll cover some of this at the end, is the Go product. It is a solution that basically covers the same area. It's a single carrier solution that'll cover anywhere from 10 to 15,000 square feet on average. But this is if you don't have any coverage within the facility. You can bring it in with an external antenna. You feed it via coax into this Go unit, and then out to this donor antenna via coax as well. We also have, there's the capability to not only switch carriers, it is a single carrier only solution, but you can switch between different carriers. So if you change, if the client changes the carrier that they're using, they can easily just go on to the app and switch from AT&T to, let's say, Verizon, and it'll automatically start boosting Verizon instead. The same thing goes here. This is the same product, the Go, but it has a mobile capability as well. So we're able to do this in vehicles for vehicle uplifts to do these products. And we've seen a lot of success here in fleets as well as RV communities. There's a lot of advantages to the product, but works very similar to this, except it's in a mobile format. We won't talk anything about Prime because Prime is overseas, but we will spend the majority of our time, because I think it's probably the most viable for those that are on the call, in the Quatra system, because it is developed for the middle price. We spend a lot of time, especially in the Quattro system, in this 500,000 square feet and under space. Our solutions are not capacity plays, so you won't ever see these installed into airports, stadiums, places with huge amount of capacity needs, tens of thousands of people. That's not where we play. We play primarily in this 500,000 square feet and under space, and there's a reason that that is a sweet spot for us, not only because of the capacity needs of those locations typically falling within those areas that we cover best, but also because that tends to be the area where the carriers do not subsidize these people to help them with in-building coverage needs. So up here, a lot of subsidy. This is where active DAS is used. So active DAS is an actual, for those that don't know, is a actual fiber backhaul from the carrier to be able to distribute that signal throughout the particular facility, and they're used in very large facilities with very high capacity. Our solution is a hybrid system that allows you to be able to use a couple different donor signal options, and which I'll get into in detail. and then distribute that throughout the facility. There are also, I mentioned, kind of passive systems. Those tend to be the smaller locations, although they are trying to go up into these spaces, not necessarily the best fit because they all operate off of coax, and I'll get onto why that we're such a better solution for this middle prize area. But this is where we primarily spend most of our time. So if these are some of your clients that you have, this is going to be a great fit for those needs. The other thing that I'll mention, the other reason why you wouldn't install the active DAS into these facilities is typically price point. As I mentioned, active DAS typically, not only is it usually subsidized by the carriers, but it also tends to fall in a $3 to $4 a square foot range. Our solution tends to fall into a 50 cents to $1 a square foot range. So it's much more palatable for the middle prize, and thus a very good option for them when they're footing the bill for these different verticals. And they fit into all kinds of different spaces. You can see that these verticals represent some of the locations that we do, but it definitely does not limit to where we're capable of. We do occasionally go up into above 500,000 square feet, but it tends to be industrial spaces, large million square foot production facilities, for example, that may need help. They don't have a large capacity. It may be a few hundred people in the building, but it's just a large area to cover. And so we do play into those environments too. And I'll get into why that is in a moment. So this is, excuse me, the basic architecture of our solution. And I mentioned there's a couple different ways for us to communicate the signal. So we do use either off-air, so you'd have an external antenna, donor antenna on the top that would be pulling in the signal from a local tower or base station. And we would do that for multiple carriers, 1, 2, or all 4. Or we can also connect to a small cell. We call that a supercell. So basically this small cell, typically, which you would get from the carrier, and we then distribute that signal rather than the small cell being the signal source and also the location within the building that you can get signal, which usually is anywhere from, depending on the building, it might be about 10 to 15,000 square feet. This allows you to shoot it into this network unit and then shoot out of it and cover more space with this small cell. Now, to give you an idea, probably 95% of our business is done via off-air. There's a couple reasons for that. One is that off-air is free. This costs money from the carrier. And also, there's a limitation on the amount of donor or the amount of coverage that you're getting from this. So typically, a small cell will cover about 64 continuous users, where the off-air, you're using the capacity of the base station. So that's why we see most of this going off-air, but occasionally we do so obviously support the small cell. And there's a particular product that we're just releasing that I'll get into that also really helps select which way you're going with this, and I'll get into the details there. But both of these are fed via coax into the network unit that typically resides in the IDF closet of the facility that you're working in, and it's where the only power requirement is for this system. So this power is powered here, and then everything that is done outside of that network unit to these smart omnidirectional antennas for coverage units is all RF over Ethernet and PoE. So no power requirements for any of these locations within the facility, and you can run up to 325 feet, and it's completely lossless. Unlike running coax, where you continue the signal would continue to degrade over time, or over distance, I should say. With this, you do not have any losses associated with that. So we can run up to 325 feet. Lossless out to these coverage units. We do have proprietary extenders that allow you to go 650 feet within the facility. So it really, when I mention these larger million square foot manufacturing facilities, that's really where this helps, is when you're trying to gain access into those further reaching parts of the facility that normally a passive system would not be a good fit for. So there's a couple things I want to touch on that also make us unique beyond this RF over Ethernet. The one thing that I mentioned, the FCC had changed their code They have a special accommodation for our technology because our technology does not harm the network, and it has the capability of only going out and boosting those channels, those bands and frequencies within the carrier's network. We're able to boost our solution at up to 100 dB a gain. If you look at everyone else that's in this part 20 part of the FCC code, they're only able to do 70 dB a gain. What that up to 70 dB, which always isn't the case, but we'll say that even if they could get the full power, that's where they would be. It means a huge amount of difference when you're talking about coverage and what we can do as far as covering the different locations and what each one of these coverage units will do. So again, lossless run, and then when you get to these areas, you're about anywhere from 10 to 15,000 square foot of coverage. I'll get into the details of how we determine that as well throughout the presentation. But this network unit will support this particular one, and the 1000 and the 2000 version will cover up to about 50,000 square feet, because each one of these are doing 10 to 15,000 square feet each. And you can do up to 4 on there. In the newest iteration, we can actually do 6 coverage units, and I'll get into the details of what the differences are between those. The other thing that I'll mention here as well is we kind of get the best of both worlds as a manufacturer. We are able to boost it up to 100 dB a gain, but we also fall into something called Part 20 in the FCC code. So much like the passive parts of the world where you're able to boost without carrier retransmission agreements, but we get up to 100 dB a gain. So it's a huge advantage there, because all the other active systems that we talked about in the stadiums require a retransmission agreement in order to do that. So not only do we have blanket approval from the FCC, but we also go through all the labs for the carriers, so we're already approved and endorsed as well on that end. So it really is a very unique area that our product fits into, and it's a very high value item as well because of those different things. So the retransmission agreement, just so everyone knows, if you've never done it before, it takes anywhere from probably 6 to 18 months to get. So that's the other thing to keep in mind if someone's looking at active DAS. If they are looking for an immediate solution, this is the solution that they would be able to utilize, not an active DAS, because it'll take them time to get that carrier approval, where we do not need it. We have blanket approval as part of Part 20 in the FCC code. So hopefully that all makes sense. And then all of this comes together and is able to be monitored by our integrators remotely. You're able to commission the system online. It'll do all the performance monitoring for you. It'll track what we call KPIs, which is things like the power, the quality of the signal, the SINAR, which is the signal to noise ratio, which is important and really what drives bars on your phone. Not necessarily the power of the signal, but the quality of the signal. But it's tracking all those things. It does antenna positioning. So it takes a lot of the things that you normally would have to manually do and automates them because of our technology. And it's what makes the carriers love our system so much, is because it's automated and no one can mess with and cause harm to the network. It also will email and text you alarm notifications if any of the parameters that you set don't fall into where they are optimized. It'll let you know about that in real time, as long as it's connected to the internet. So really what this does, it does 2 things. It either eliminates truck rolls altogether, which obviously we all know is a big cost component to any system that you deploy. But if it does require a truck roll, let's say it's telling you, the system will actually tell you what the problem is. So let's say it says, hey, you've got a bad Cat5 cable in between this coverage and network unit. It'll tell you exactly where that failure point is. So if you do have to roll a truck, you're going out and you are able to fix the problem specifically. You don't have to go out and spend a day trying to figure out where the problem is. It's telling you exactly where the problem is and where you need to fix it. So it's a really powerful system. So we'll get into a little bit in the weeds here just to explain. As I mentioned, there's some differences because most of your clients, if they've tried to solve this before, they may have tried to do it with a passive system. And there's a lot of things that are different about our solution than the passive BDAs of the world out there. So just a real quick lesson on this. We act very similar to what your phone does on the network. So it's power controlled, it's channel priority, all the signal quality metrics that happen on your phone happen on our system as well. We don't ever desensitize the network at all. And with the thousands of units that we have deployed across the country, we've never once, and I mean once, been shut down. And that is a big deal. It tells you all you need to know about the safety of the system on the network, where you do have those problems, definite potential problems on a passive system with the BDA, and one of the reasons why they have such a reduction in their power gain. We also, will never go into oscillation, which is a technical word meaning that we're not going to cause feedback on the network, basically. So this is a system kind of comparing the two options. Again, completely lossless here for all these runs. The coverage unit acts as a smart directional antenna. And this is the system if you're using a passive system. So you're running coax that has losses here, then the taps and the splitters that have losses, which basically, as you continue to keep running this out, your coverage bubble, even at up to 70 dB a gain, keeps getting smaller as you keep getting down further down the line with this run on a passive amplifier. You also have PIM issues and unequal coverage problems, which I'll touch on briefly. But in our system, you don't have that at all. It's all run here, and you're obviously able to monitor all these coverage units out here because all that information is driving back to the network unit, so you can see all the things remotely. I'll get into this passive capabilities on the CU later. It really comes into play on our new 4000 system, which I will cover. This is also a challenge if you've ever done a passive BDA system. I'll just briefly cover this, but basically the difference with our system, I mentioned that all these radios on our Quattro system are independently power controlled. And why that's important is you could have a Verizon signal, let's say outside the facility, and maybe the Verizon coverage isn't that bad inside the facility. So you only need 10 dB a gain to get the full power. Well, this system, the coax passive system, will give it 10 dB a gain to get the full power. But if you need 40 dB to gain to get the full power on a T-Mobile system, it'll only give it 10 dB a gain. So at the best, you end up with a duplication of what's on the outside of the building, which may or not be the best situation. With our system, it works somewhat the same in the fact that it'll give it 10 dB a gain if you need to get the full power. Again, full power being 100 dB a gain, not 70. But the other thing it'll do is if this needs 40 dB a gain, it'll give it 40 dB a gain to get it to full power. So it's called a near-far problem on the passive system, and this is solved with our solution. So you end up with a much more consistent, equal coverage power output of the coverage unit versus, like I said, at the best, a duplication of what's on the outside of the building. So and this covers a little bit about what 100 dB of gain means versus 60 to 70 dB a gain. Again, just suffice to say it's a much larger footprint, so a lot less equipment having to be installed in this facility. So I'll get into the different flavors of the product. The Quatra has actually 3 different products as of this year. The Quattro 1000 is what we started off with, and really what we started to do as a company throughout the world, and really what we do primarily out throughout the world as a whole, and it's just a single carrier. So the reason for that is because the carriers usually only care about themselves. So if they are doing a coverage, they're only going to help out whatever their client is that needs this particular coverage. We still do a lot of these systems because some companies only have the need for the single carrier to cover. So it's also a MIMO system, so it adds some speed capacity to that when it's a MIMO system. But again, for 1 network unit and 4 coverage units, and then you can continue to keep building onto that. So if you have a 200,000 square feet, and I'll show you what that looks like in real life in some later slides, but you're able to just continue to boost more locations throughout that. We also have a 2000 system that is paired, and these carrier configurations are set, so this is how it has to be paired. but the coverage unit will do AT&T and Verizon on one, and then Sprint and T-Mobile on the other option. And this is a CISO system. We also just came out and released the Quatra 4000, which, as you could probably assume, does all 4 carriers in one setting. It is a little bit different in the architecture of how we do things, and I'll get into some of those details now. But one of the big things that this does differently, well, there's a lot of different things, but one of them is that it has up to 6 coverage units per network unit. So you can cover a little bit more ground, about 75,000 square feet on average, and even more so if you're doing some other things that this allows you to do. So I mentioned that in the past, you'd either have to select small cell or off air to determine the donor signal that's coming in. With this system, it allows you to, because there are independent ports on each one of these network units, it allows you to feed small cell for one carrier, but go off air for another. So let's say you have a small cell for AT&T, but you want to go off air for Verizon. It'll allow you to do that because there's independent ports on each one of for each 4 of the carriers headed into this network unit. And then out from there, we run Cat5e just like the other one, Cat5e or greater, out to the coverage unit. But what this one allows you to do a little bit easier is to drive passive antennas off of it. So where we're seeing this really apply is in hotels, hospitals, areas that have narrow hallways with rooms on both sides where you might want to just build a bunch of different coverage bubbles down the hallway. So you bring that power, that lossless power to, let's say, this floor, 5 floors below. There's no losses here to the Cat5, and then you run passives out down the hallway where don't have enough losses really that it's not as bad of losses. You still can cover those locations. So it's been a really powerful tool. It also covers things like TDD in this version of the product. So in Sprint side, we can do 3G. And we do have a Part 90 version that covers some other channels that don't fall into Part 20. So those would require retransmission agreements for those carriers that you're trying to cover those specific bands. I would say for the most part, primarily, we see most people using the Part 20 because it's a quick install and those retransmissions aren't required. But there may be some instances if you're trying to get band 71 for T-Mobile, for example, where this 4000i might be a better choice. Again, independent ports, a couple other things that are unique. One of the pain points of the 1000 and 2000 for our installers sometimes is the fact that they need an IT connection, not only to monitor the system, but to commission it. We have used LTE modems to overcome those challenges where you're in a government facility or some other place that's very sensitive about, even though our products are safe to sit on their network, if they won't give you a network connection, you're able to use an LTE modem. In this case, we actually integrated it into the system, and it comes with a 1-year service contract as well. That will be a support contract from us. It ships with an active SIM for a year. That then you can re-up with that, but it has an LTE modem that's already active in it, so you don't need that IT connection anymore. It does allow for it if you'd like to use that, but there is some unique differences. The other differences is that the CU is a little different. The coverage unit is a little different in the fact that it's a little bit heavier than the previous versions. The 1000 and 2000 look a lot like wireless access points and install a lot like wireless access points where they're light enough to install into a ceiling grid. This product, you would have to install it to something more substantial on the coverage unit and then drive either a passive or it comes with a blade antenna to utilize. So a little bit different architecture, but some really great advantages to the 4000 when you have a 4-carrier solution. We do offer, this is kind of what all the products look like on the 1000 and 2000. We do offer some great antenna options. This is the one we tend to default to when you're going off air because it really gives a great signal to noise result on this, which again, as I mentioned, does drive the bars in your phone. And it also creates a much, so if you have a weaker signal, it'll help with the gain on this particular LPDA antenna, but we have a number of different choices there. as integrators, we also realized that one of the problems is just finding out where the best signal is coming from. And in the past, the only really reasonable solutions would just tell you the most powerful signal. But this solution actually that we came out with at the end of last year, the Cel Fi Compass, allows you to find the best signal and to also commission the system with the Quatra system. And it connects, it's basically the size of a brick, and then it connects to your smartphone, whether it's an Android or an iPhone, it doesn't matter. It is an app, a free app that comes with it, and it allows you to test for all the different carriers and gives you all the metrics for the carriers, not only within the building, but up on the roof as well. So you can do a test. The initial iteration won't have this, does not have this option, but there will be a walk test capability of this where you can download onto the smartphone a map of the facility and do a walk test as well with this product that'll be coming out in the next version of the product later this year. But it's a really powerful tool. It's a lot better than having to have 4 different phones, Android phones, and then having to have 4 different SIMs. This is all in one system, and a really great tool that we came out with to help those pain points. And then it also does the antenna positioning for the compass, along kind of partnering with the Quatra system to be able to know which direction you need to point the antenna at. So really, again, a very powerful tool. We do have training online to be able to get up to speed on all of our products, and it also acts as the access to the portal for our system so that you can jump on and see these systems at any time once they're connected to the internet. Very easy to go through. You do the site survey, you install the cables, you plug it in, and you commission it. It's a very easy system once you get used to it, especially those of you who, I think most of you have experience doing wireless access points. This is almost like combining wireless access points with RF. If that makes any sense to you, it's almost that kind of approach. We do have some tools out there as well. This is a Quatra planner on our website that allows you to plug in a square footage. We do a lot of hand holding early on as a company just to make sure you feel comfortable, because while it is easy to get to know this system, it is probably different than anything you've ever done before. So we do a lot of hand holding here, but this Quatra planner tool is very user-friendly. You basically just put in the square footage of the location, you put the type of area within the facility that you're dealing with, whether it's open, you know, what percentages those areas make up of that total square footage. You hit calculate, and it comes up with the number of network units and coverage units that you'll need. This is for the 1000 and 2000. There is a 4000 version coming out for this very shortly, since that product is literally just launched this year. So this is what the Wave portal looks like. So this is what your systems would look like. This would bring up all the systems that you have on the map, and then you'd be able to drill down into them and see them remotely. You can see all the KPIs, as I mentioned here, all the different coverage units. You can power on and off units from your desktop. You can drill down into them and see which bands and frequencies they're all on remotely. And it's just a really powerful tool. It's probably our integrators one of their favorite tools. This is what the system looks like in reality. So this, you can see how much space it takes up in the IDF closet, not a whole lot of space. And if you've been kind of tracking with me on the square footage that this covers, this is about 300,000 square feet is what this on average would cover. If you were doing 1 or 2 carriers, in this case, this is before the 4,000 and still may have application for some installs, but this is doubling up on the 2000. So this is, one of them is doing the AT&T and Verizon coverage. One of them doing is Sprint and T-Mobile. That's why you have 2 next to each other, but you can see what they look like. They look like wireless access points in the ceiling. And then these are the donor antennas that are feeding down into that IDF closet to these network units. If this was a 4 carrier solution and you were using the 2000, it would basically do 150,000 square feet, because 3 of these would be doing AT&T and Verizon, 3 would be doing Sprint and T-Mobile. So I mentioned 50 cents to $1 a square foot installed, and some of that plays into how many carriers you're needing to utilize, and obviously the 1,000, 2,000, 4,000 have different price points associated with them. But the other thing that's dictated by is the type of facility that you're dealing with. So I like to usually show these two because I think they're um, good examples of why that may move up or down a little bit. So this is a best case scenario. I like to show this. This is a wide open, high ceiling, no obstructions really in this facility. It's just a big open manufacturing plant. And I think we used a total of 6 CUs. This is in the lower bands to cover 376,000 square feet. So if you do the math there, you're at what, 60, 70,000 square feet per coverage unit. So way above that on average 10 to 15,000 square feet. But it's because of that 100 dB a gain and the fact that our system will just go crazy in here. It'll really cover a lot of ground for these types of facilities. So instead of 50 cents to $1 a square foot, you're probably somewhere around 10 cents or lower per square foot in this particular scenario. So best case, this is a worst case, which probably may be more applicable to some of you on the phone. And this is a tough environment. It's an old courthouse. Everything in this building, interior walls are all concrete. So we still have the same physics that are applied even with that up to 100 dB a gain. It's still going to take a lot to penetrate those areas. So as you can see, this is just with one coverage unit installed. You can see it's blasting down the hallway here. But as you get into some of these areas where you have to overcome the concrete, it's starting to lose signal here. So instead of 10 to 15,000 square feet, this may be closer to 5 to 10,000 square feet of per coverage units. You'll just need more coverage units in here. Still a very powerful system. If you can still get the up to 100 dB a gain, then it's still going to play very well for you and should still fall into that 50 cents to $1 a square foot range. But again, probably closer to that upper range. I'll cover a few of the products. We already talked about this product. I don't think many of you on the phone will have the need for this too often. I kind of covered what this does wirelessly, but it is one of our first products and still used a lot, especially for customer retention. But I will spend some time on the go. I mentioned what this product does early on in the presentation. It is a great one for a smaller satellite type facility that just needs maybe a single carrier. We have seen situations where they're using 2, maybe even 3 carriers and just doubling up or tripling up on these to provide service because it is a value add at that point rather than doing Quatra for some of these smaller locations. It will do a single carrier at one time. And again, it does mobile. It does up to 100 dB a gain, just like the Quattro system does in the stationary mode. If you do mobile, I think it says 65, but I think it's actually 60 according to the FCC code. So it'll do up to 60 dB in the mobile mode in this, but you can switch. So I mentioned the RV situation. There might be other things like fire trucks and those types of products that when they get to a stopping point, they can actually switch to static mode to allow them to do up to 100 dB gain, which will, depending on the isolation of where you have this donor antenna, it'll cover a larger bubble around the mobile device or mobile vehicle. We also have the ability to cover outdoor areas and still remotely monitor them. So this Go product is a NEMA 4 product as it is. So you can hit this thing with a fire hose and it's still going to run. But some of these components are not. And so we created this Go RMOE to be able to support remote management. We use these a lot in oil rigs, fracking, all those outdoor areas that need outdoor coverage, but kind of remote type locations. So this is a little bit what the app looks like, where you can switch the difference. It's very user friendly, and it does show you what it's boosting, similar to what I mentioned on the Quattro system as well. This is an example of kind of the setup that you would do if you had a couple different carriers and still wanted to use Go. Pretty simplistic, but again, all coax runs. So keep in mind that as you run, you lose the signal degrades over time. We've got some great examples of case studies on our website. I'm not going to go too far into these, although there's some really cool ones like this one that just kind of 15-inch pane glass that we're able to still utilize that up to 100 dB a gain signal. But I'm not going to get too far into these case studies. We have a lot of them in different verticals on our website. So if you're interested, you can definitely check those out at celfi.com. So I won't dwell too much on that. And with that, I'll turn it over to Austin. I'm not sure how many questions or if there are any questions, but I'm happy to answer anything else. And I appreciate the opportunity that you guys gave me to talk.
Yeah, thank you so much, Jim. Yeah, we do have a couple questions, and then if anyone else wants to type in their questions right now, we can answer those as well. The question we have right now at the moment was when we were going over the Quatra 4000, does the network unit have a built-in antenna? And also kind of building off that, does the coverage unit have a built-in antenna?
The answer to that on the Quatra 4000 is no. They do not have interior antennas on either one. So the only antenna would be when you connect this antenna panel to the actual coverage unit, or in the case of, as I mentioned, driving passives on there, we just came out with this low profile antenna that's also a passive antenna that you can drive off of that as well, down and obviously do multiples. But no, there is no antenna that's producing signal from the network unit other than to the coverage units, and the coverage units only produce the signal when you either attach a micro panel or you attach another passive antenna like that.
Okay, great. And then we have another one. This person does a lot of work in the Caribbean. Does the Quatra support other carriers?
So the Quatra is supported globally by about 200 different network providers in about 100 different countries. The Caribbean, I'd have to know a little bit more detail. I mean, that's something that we can get a follow-up on as to which carrier it is, and we can investigate that for them to see if it is, in fact, covered with that carrier. But because we're carrier specific, it's not a dumb repeater. It's a carrier specific solution. So it would have to be something that's approved on their network. So the answer is yes, as long as we already have approval from that carrier. So I can investigate that if they give us more details.
Awesome. Yeah, that does it for the questions. So I want to thank everyone for coming today. If you could fill out that quick survey when you get a chance after this, and see you guys next time. You guys have a lovely Tuesday.
Thanks, everybody.